Good morning. Good to see Noah here, as usual. Noah, you deserve a special award for being here so regularly and asking good questions. Also, I'm going to get right to it. This one shouldn't be too long today. What we have here is in exercise 1 and 2, determine the quadrants containing the terminal side of the angles. And this was in problem 1, we have radian measure. And in problem 2, these ones are in degree measure. So basically, if you look at a standard circle, so a standard circle here, we start here at 0, and for A we have negative 300, so that's negative 300 is going around this way to negative 300, so that's going to be quadrant 1, negative 300, and then 210 is going to be coming this way, about like this. This will be 30 degrees dot, so this is going to be quadrant 2. Be sure to chime in if you have any questions as we go along here. So, but that's it, problem 2. Problem 4. Find a positive and negative angle coterminal with the given angle. So what we have here is this. We have pi over 3, which is going to be right here, about the same as 60 degrees, pi over 3. So to get a positive and negative angle, if we add 2 pi or subtract 2 pi, that's going to give us a coterminal angle. And 2 pi is the same as 6 pi over 3. Well, why is that helpful to us? Because we have pi over 3, so that's going to give us a common denominator. So pi over 3 plus 6 pi over 3 is going to be 7 pi over 3. So coterminal, meaning we just went pi over 3 and went once more around. And also we have pi over 3 minus 6 pi over 3, which is going to be effectively 360 degrees, but in the negative direction, like this. Yeah, negative direction. So that's going to be negative 5 pi over 3. So there it is. Problem 4. Let's go on 6. Again, positive and negative angle, coterminal given. This time we're going to have negative 120 degrees. Instead of adding radians, we're going to go plus or minus 360 degrees. So negative 120 degrees plus 360 degrees is going to be a coterminal angle. So negative 120 plus 360 is going to be 240 degrees. There's our coterminal angle. And also negative 120 degrees minus 360 degrees. That will be a coterminal angle that's negative. So negative 120 minus 360 is going to be negative 480 degrees. And so that is going to be that. Okay, number 8. 7 and 8 is write a standard form equation for a circle. And what we have for a standard equation for a circle is this one. We have x minus h squared plus quantity y minus k squared equals r squared. So what we have is the center is at 0, so there's no translation to be done left or right. So h is 0. So we're going to have this x squared, and it's going to be plus, and our we're going to have k is equal to -4. So we're going to have is y minus -4. It's going to be y plus 4 squared, and equals r squared. So that's going to be 3 squared or 9. So there we are. Okay, and then we did number 9. Number 9 was in the video. I realized that number 10 was not on the video. It's very similar to number 9. And so what you have is you want to find the side C over here, and then the third side. So you could just say A is equal to 9, B is equal to 6. So we have is C squared is equal to, I'll just write the formula, A squared plus B squared minus 2AB cosine C. And so that's going to be C squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cosine 40 degrees. And what we're going to do to solve for C, I'm going to make a little shortcut here. I'm going to erase this square right here. It's really, what I'm doing is I'm taking the square root of both sides, what this amounts to. So C is going to be equal to the square root of all that. So C, going to our calculator, is, let me get out of here, and we are in radians, and our problem is in degrees. Let me go ahead and change the mode and change this over to degrees. There we go. And get out of here. So we get the square root of 9 squared plus 6 squared minus 2 times 9 times 6 times cosine 40 degrees. And let's see if everything is there. That looks good. So C is going to be about 5. If we want to go to 1,000th place, we go 5.8. We'll go to 100th place, 5.85. We'll call this. So C, we'll say C is approximately equal to 5.85. Okay. Next, we have this exercise 1 through 6. It says, in exercise 1 through 4, the polar coordinates of a point are given. Find its rectangular coordinates. We have our cosine theta equals x, r sine theta is equal to y. Now, 5 pi over 4 would be down here. So in degrees, that'd be 225 degrees, I think. And we have -4. So x is equal to -4, and cosine of 5 pi over 4 is going to be negative square root of 2 over 2. Now I realize you can just put in negative 200, negative 220, 225 degrees, -4, 225 degrees. But -4 times negative square root of 2 over 2, the negatives are going to cancel each other. And 4 over 2 is going to cancel become 2. So we have 2 square root of 2 is our x value. So x, I'll just leave it like that. And then y equals -4, and the sine of 5 pi over 4 is also going to be negative square root of 2 over 2. So that's going to be also 2 square root of 2. So our rectangular coordinates, the rectangular coordinates is going to be this one right here. Why is it square root of 2 over 2? Okay, that's an excellent question. Okay, no, I'm going to answer that question here. I appreciate you asking it. Okay, Noah, if you go back, you remember the unit circle here, and what we have is 5 pi over 4 is down here. And it's the same as negative 200, the same as 225 degrees. What you have here is the radius here in the unit circle. So r is equal to 1, right? And so your cosine is what your x value is, or this would be your adjacent side, right? And this down here would be your opposite side. And so cosine, I'm going to write this to the right. So cosine of 5 pi over 4 is going to be adjacent over hypotenuse. Well, your adjacent is going to be the, so if you have like your, let me just write it, do a triangle, 45, 45, 90 triangle. So what you have, if your hypotenuse is 1, the 45, 45, 90 triangle is according to the format x, x, x square root of 2. And so what is going to happen here to find out what x is, you have to divide by square root of 2. So what we have is we divide by square root of 2, divide by square root of 2, if x is 1. If this is 1, then we have 1 over square root of 2. Okay, 1 over square root of 2, if we rationalize this and multiply the numerator and denominator both by square root of 2, we get square root of 2 over 2. And that's how we get square root of 2 over 2. Okay, so that's where that comes from. And then you can just put this in a calculator. Now, in a calculator, you're going to get a decimalized answer. You're going to get, wait a second. I think I missed your question. I missed your question. I answered something that you didn't ask. I wrote them down. I just mistranscribed. That's all I did. So our answers are going to be 2 square root of 2, comma, 2 square root of 2. I got around to really answering your question finally. Sorry about that. No. You would, if we were in class, you would have stopped me a long time ago. We would have got it straightened out. But I think we eventually, oops, I put square root of 3 here too. My gosh, I can't do anything back here. There we go. And it's sort of counterintuitive because the point is up here in quadrant 1, but you've got a negative radius. So that's kind of weird about polar coordinates. Go on to this one here. Now we have -1. Yeah, and 315 degrees. Now 315 degrees is going to be right down here. That's going to be the same thing as, I think, 7 pi over 4. So it's going to be x equals r cosine theta. And cosine theta is going to be square root of 2 over 2. So x equals -1 times square root of 2 over 2, which equals negative square root of 2 over 2. So that is our x coordinate. Y equals r sine theta. And that's going to be -1. And here we have sine. Down here is negative. So we're going to have negative square root of 2 over 2. And we multiply these together. Negative and negative will cancel each other. So we get square root of 2 over 2. So for this one, our rectangular coordinate pair is going to be negative square root of 2 over 2. Comma square root of 2 over 2. So that'll be that one. And if you just use a calculator, you'll get a decimalized answer. And if you do that, that's no tragedy. Okay, let's go on to number 6. Now, one thing that could be helpful to do sometimes is if you have trouble with with radians, is you can quickly change these things into degrees. So pi over 4 is like 45 degrees. Pi over 2 is 90 degrees. 5 pi over 6 is 150 degrees. Pi is 180 degrees. 4 pi over 3, let's see, that's going to be going out the unit circle, the polar coordinate graph paper. There's x, and we got y. This, not very straight looking lines, but that'll just have to do. So 4 pi over 3 is going to be down here. So that's going to be like equivalent to 240 degrees. And then obviously 2 pi is 360 degrees. Now we have 2 cosecant theta. Now, what is cosecant theta? Cosecant theta equals 1 over sine theta. So they're reciprocals of each other, sine and cosecant. So what I recommend doing for this one here is r is equal to 2 over sine theta. So you can just write it in like this. So it'll be like, and you can use your calculator, 1 over sine 45 degrees, and that might be a faster way to do it. So let's just look at this. 1 over sine 45 degrees. So 1.41 approximately. Sine of pi over 2 is 1. Because it's right up here, sine of pi over 2 is 1. So that would be 1 or 2 over 1. That would be 2. Okay. Next. Oops, I got that wrong. It should be 2. Yeah, 2 over. Oh man, I got this wrong. Like this here. This would be times 2. There we go. So 2.83 is what this would be. Just fix that. 2.83. I think this one is right. Now we have one. Next one's going to be 2 divided by sine of 150 degrees. Because I know what that's going to be. 4. I knew that. Because I knew it was the sine was 1/2. So it would be 2 divided by 1/2. And for pi, we're going to have 2 over 0. Well, 2 divided by 0, that's going to be undefined. The sine of 0 is. Then for 4 pi over 3, it would be 2 divided by sine 240 degrees. So we get negative 2.31. And then for 2 over 2 sine 2 pi, that's going to be undefined. Let's go put this in, go graph these here. If we have pi 0.83, so we can go 1, 2, so 2.83 would be about right here. So that's 1 point. Next for pi over 2, we have 2. So here's pi over 2, 2. So here's pi over 2 straight up there. We have 5 pi over 6, which is right here. It's going to be 4. So 1, It's going to be 5, 5, 6, right here. So we have 1, 1, 2, 3, 4. Okay, for pi, we will have undefined. For 4 pi over 3, which is going to be right down here, 4 pi over 3, we have negative 2.31. So we got to go up here and go to negative 2.31, which is going to be 1, 2, 3, should be about right here, negative 2.31. And then 2 pi is undefined. So what do we have here? I'll show you what that is. That's going to be this looking thing right here. So really, it's going to be the line y equals 2. That's going to be the coordinate equation of that. And I want to show you this. 2 cosecant. It's sort of an introduction to polar equations. You go to your calculator, and you go to mode, and going down here to functions, you can go to graph polar, press enter, go here, and we can put in 2 over sine theta max. So go here, alpha, alpha, 2 over sine theta, equals 6. So you have a horizontal line, y equals 2. That's a polar equation. Anyway, that's it. Any other questions? I think we've covered it for today. I'm ready to call this a day. No last minute questions. Okay, well then, I guess we can call that okay, good. Noah, anybody else is working? Take care. Have a good rest of the day and a great weekend. We'll continue on with polar coordinates and eventually segue into polar equations. I gave you a bit of an introduction today with that. Take care. Bye.